2, 1. When you're studying vectors, and most likely this is going to be kind of the introductory component of vectors for you. So as you're going through kind of all the different concepts, you might run into this interesting concept in terms of studying velocities. So velocities are vectors, so they're basically a speed with a direction that you have. And in particular, what you're going to be kind of thinking about is the directions that either maybe an aircraft or a ship or even a car or something of that nature, okay, something with respect to ground travel, is going to be heading. And when you do encounter perturbations when you're traveling, so you can imagine if it's an aircraft or a ship or something. So here on the left hand side, okay, so I'm showing that there is some wind which is blowing from a certain direction. So obviously it does have an impact on the actual movement of a particular ship or an aircraft. Now, if it's a ship, or even if it is an aircraft, there's air currents that you run into, and then there's also kind of water currents that you might be running into, which are in different directions. So when you're studying these kinds of problems, you realize that if you're a ship, you're going to have to actually be heading in a different direction than your desired kind of which we call a bearing direction, which is the exactly direction where you want to be heading. So you want to be kind of off, kind of shifting away from the perturbations of the wind and the currents or anything else, so that you do end up where you want to go. Because if you're going to be thinking that you want to be able to head east, as you have shown over here, okay, so if you want to go in that east direction, for instance, then what would happen is this particular wind, so I'm going to just duplicate it, well, that's going to take you off guard, okay, in some direction. So let's say that, and then this particular current, okay, that you would have would also offset you. So notice that what you would have is, so if you were actually just thinking, okay, this is where I want to be able to go, then you're going to run into this problem, okay, that you're going to be heading in this direction right there, because you're going to be offset by the wind and then the current, which is pushing you away from where you want to be able to go. So what we would like to do is we would want to be able to compensate for these. So if we know what these currents and winds are, so let me just remove this for the moment, okay, so this, for instance, so I'm going to just remove that. Let's remove this as well. So what we want to be able to do is this. So if this is where we want to go, so I'm going to just kind of place this vector over here. That's the direction that we want to be able to be heading, and we're going to be moving at some particular speed, for instance. Then we want to compensate for this. So what we would do is, so for instance, if there is a wind and a current, so I'm going to duplicate that. And I'm going to put it, so notice I'm putting it head to head, okay, there, right there in that direction. And then the wind, so I'm going to duplicate that, okay, and this is going to be pushing it in this direction. And what I'm trying to do is I'm trying to send my particular ship or aircraft, okay, in that direction of the blue, because notice that the resultant vector is going to be, okay, exactly this. If I would be heading in this direction, which is designated with the blue, so if that's my heading designated, and I have that wind and then the current, which are also vectors, so they're going to sway me away, right? And they're going to be pointing me in the direction that I eventually want to go. So this is kind of compensating for the two perturbations that I have. Now that should make sense to you, right? So if you're going to be going in this direction, and then you have your wind and current, which are also vectors, which are pushing you in some place else, well, you're going to get pushed over so that you can get into your bearing, okay, the resultant direction that you actually desire. So what we do is the blue is actually referred to as the heading direction. So that is where you want to be heading so that you end up at your desired or the bearing direction, okay, which is pointed out here in red, right? So that is the difference. So when you are trying to overcome any currents or perturbations, you want to be setting your heading actually in a different direction than the one that you desire to overcome. If there are no winds, no currents, or any other perturbations, then go ahead. You can be going into where your heading is going to be equal to your bearing, okay, direction, okay? So you can do that. But otherwise, you might be steering it a little bit off course so that the actual currents and winds push you back into where you want to be able to go. And you can imagine that, like if you're traveling as an aircraft or you're traveling in terms of water, you're going to be moving, okay, in those. Now, when there's ground velocity, kind of if you're traveling on the ground, then very often we just refer to this as the ground velocity, right? So that is the actual velocity that we're trying to be heading in, okay, in terms of our bearing. So if you're thinking of the bearing, that would be your ground velocity that you want to be going into. But if you're referring to water or the air, then you call them typically heading or bearing. Not that it matters. Those names are, those are probably going to escape from your mind. But what you should be able to do is if somebody asks you, please calculate the heading direction, if the bearing is going to be, given, for example, this is where you want to go at this speed and this direction, and you have these currents and whatever perturbations present, you should be able to do that, right? To be able to find those particular results. So here is an interesting example which talks exactly like this. Now, this isn't going to be anything new if you have done these particular style of questions with regards to vectors, which is really you're just calculating resultant vectors, okay, or a vector which is missing, right, within here. So let's take a look what they give us. So here's a ship. It's under two perturbations, so it's kind of like the one that I pointed out up above there. Now, typically, maybe in the starting point, as you're doing this, maybe in grade 12 or in first year, maybe there's going to only be one perturbation, right, which is going to shift you just off course. It's rarely you're going to get two. So two is a harder problem. But we can certainly handle it if you understand the addition and subtraction of vectors. So here it tells us that the current is flowing at a velocity of 14 kilometers an hour. And it is at a bearing of basically 30 degrees. So it looks like this is kind of true bearing, which is with respect to north. So if I would draw this out, so 14, so this is the current is flowing at a velocity of 14 kilometers at a bearing of, all right. So let's try to draw this out and then see what is actually happening. So I'm going to draw my x-axis. I won't really scale this properly, okay, maybe, but let's see what these currents are. So I'll keep it in orange as I did in the explanation. So I have 14 at 30 degrees, okay, so this is going to be 14, so it's going to be rather small, okay, within here, so let's put that. Now 30 degrees, so that means this is 30 degrees right there, okay, so this is 30 degrees in this way. So that is the current maybe on that particular ship. Now the wind is coming in at 135 degrees and blowing at 38 kilometers an hour. So this one's you have to kind of be careful here because the wind is coming in at you. So it is coming in from 135 degrees. So I guess, 135 degrees. So that would have been 45 to east. So it's going to be like this. Now, the wind it's 38, so that one is 14. It's going to be a little bit bigger. Okay, so it's going to probably be something like this. But now be careful because it's not going to be this, right? Because the wind is coming in at 138. So it's coming in at you as you're moving along. So the arrow isn't in this direction. Okay, the arrow is actually in this direction. That's where the arrow is. So let me just redraw this. I'm going to delete this. So this is going to be like this. So that's where it's coming in. And you know that this angle right here, so that angle, okay, starting from that is 135 degrees, which means that this angle right here is 45 degrees because that's 90 plus 45 right there. So those are my two pieces. The ship itself wants to be moving east with a speed of 80 kilometers an hour. So this is really the desired bearing that we want. So 80 kilometers an hour, so it's going to be moving kind of in this direction. All right, so let's say that's what it wants. Let me redraw this, okay, as an arrow. Okay, so let's say it's something of this nature, right? So that is east. Now I can remove all of this junk if I wanted to, okay, in terms of the Cartesian, okay, x and y axes, but I'll just keep it, I guess, for the moment. Now we know all of those values, so what we will have is this one is 14, it's all kilometers per hour. This one is 38, this is also kilometers per hour, and we want to be heading at 80 kilometers an hour, right there, east. So what should the heading be? So we have the bearing direction, right? And then we want to know what the heading is. Okay, so you know, how would this all work out in here if you wanted to be able to solve this, okay, throughout? So it's, you know, ultimately what we have is this. I can label these in terms of vectors altogether. So let me call this one, so this is going to be V1. Let me call this one V2. All right. Let me call this one, because this is my resultant, that's my bearing. So I'll call this R. All right. Okay, just for the resultant. And then I'm going to have my heading one. So what you really want is this. You want V1 plus V2 plus, okay, R. So I'm going to call it H for the heading direction. So I'm going to call it H. All right, and that is supposed to be equal to your resultant. That's what you really are looking for, right? Ultimately, that's what we want. Okay, so now for our resultant, so on the right-hand side, because there's you know, three of them. If it was two, then you know, I can very easily kind of go back and start using the cosine law and then the sine law to find it all out. Here I can actually break it down, okay, into all its components and then find out what this will be. So that's what I would have in there. All right, so let's break this down completely. So I'm going to do the following. I'm going to break down V1 in terms of its x components, and I'm going to break it down in terms of its y components. I'm going to do the same thing. I'm going to take V2, I'm going to break it down in terms of its x component, and I'm going to break it down in terms of its y component, right? Now, my resultant vector, so that I have in here, so really, okay, what I will have, I can break down my resultant, which I can do already. So clearly on the x side, I know that this is 80, okay, at 0 degrees there to the horizontal. So I'll kind of switch over. It's going to be at 0 degrees to the horizontal. And then my y component really is 0, right? Because it's not going anywhere. So this is what I really want to be able to find. Now, if you were finding this out, you know, so if you were solving this, if you want to solve for h, well, that shouldn't really be a big deal. For us, because what we would have is this. You're going to have that h is equal to, and you're going to have your resultant vector, and then you can bring the other vectors over. So you're basically just subtracting these two components, okay, from it. So this is what you're going to have. You're going to have the addition of its opposite vectors, and that is your h, right? So we can certainly do that, okay, within here. To find out. So just the directions are all going to change on V1 and V2. Okay, so that's what we're going to try to do. So let me find the H and the Y components in here. So for V1, so I have it at, so this is 14. And so what I'm going to get is, so within here, this is going to be 14. So that's for that vector. And that is going to be, so if I go in here, right? So this is what I'm going to have. I'm going to drop this down. So if that's 30, so that means this is 60. So it's cos of 60. That's what I have there. That's going to be this. So this is cos of 60. So I can find out exactly what this is. My y is going to be 14 sine of 60. So that's what I have there. So that's my y component for that. My v2, so what I have in there, so this one I'm going to be careful with. So notice that you can, so if I take this, let me duplicate it. That's not what I wanted. Try to move it over, so it's the same thing as placing it there, right? So that's where it's pointing, and that is at a 45-degree angle, so it's 38. It's going to be 38. It's going to be cos of 45, and this is going to be 38, and then sine of 45. Now the signs of these, so notice v1, okay, the x is positive, it's to the right, and then the y is up, okay, so that's also positive. So both of these are going to be positive, okay, in the positive direction based the way that I drew it out. My v2, because I moved it into the second quadrant there, so if I take the cos of the 45 and the sine of 45, so my x is going to now be negative, okay, in this direction. So this is going to be x in this negative, and then my y is actually positive, right? So that's what I have in there, and I can find out what those values all are. My r I already have. Okay, so I have all of those. Okay, so let me just compute these. I'll put the numbers in there. I'll do that in fast forward fashion. All right, so welcome back. Okay, so I just put in all the numbers. So there we have it. And now in terms of finding this out, so my resultant vector, so what I'm going to do here is I'm going to kind of use my properties. So within here, so if this is negative, it's the same thing as this, so v1 plus v2, right? So I can find out what those are because I can add up my x and y components, and then it's going to be the opposite of that, okay, that I'm going to be taking in because of this particular, okay, subtraction that I have in here. So let me do that, okay? So within here, so I can find this, so I can find out exactly what this is. So the x component of this, and then the y component of that I can do directly. I already have my r, right? So the x component of r, so this one was 80, and then my y, so this one was 0. So let me just add those up in there. So I'm gonna have my x, so 7 minus 26.87, so that is negative 19.87. My y is going to be 12.12 plus 26.87, it's 38.99. All right. Okay, so that's what I would have. So my resultant vector, so that I would have in there. So, okay, if I would draw this out, just want to show you. Okay, if I was breaking this down. Okay, so I'm just going to plot this one for us. So negative, so it's going to be, so it's going to go in the negative direction. So let's say it's approximately this, where each square is about 10. And then, okay, so it's going to go up. So again, let's say each square. So that means it's going to go up somewhere along here. So that's this is my V1 plus my V2. Okay. Now I want the opposite of that, right? Okay, so because of that subtraction, I want the opposite of that result, which really means just the directions have changed. So this is going to go just in this direction, but it's going to be the same. It's going to be like that. And all that that does is it just changes my x and my y. So this changes my x and my y, and then I can find out the final result. So that means that r, so notice my x is going to be 80. Now this is going to be changed now to plus, so it's going to be plus 19.87. That's my x component. And then, so that's my x. And then my y component is going to be 0. And then it's going to be minus 38.99. And now I have the result for my h right there. So there you go. So my h, the component, so for x, is going to be, I guess, 99.87. And then my h for my y component is going to be negative 38.99. So I have now found this, right? So I have found my h, and that would have been my heading, okay, in terms of trying to figure out what that would be. And so let me clean this back out completely just to make it, you know, super nice and clean here. Let me just keep the vectors on their own without any of these angles or anything. So now, okay, this is going to be a little tricky, okay, for you to think about. Our result is this. This is our resultant vector, right? So that means that these are the perturbations. So we have to kind of be careful in here. So, okay, we know we want to end up over here, right? That's at the head of that result. That's what we want. That's where we want to end up. Okay, and now, so if I do that, what's going to happen, it's going to look very strange to you, but our heading, okay, so if we were, our vector, okay, well, I'm missing the arrow there, but you can imagine the arrow right there. This is your heading that you would have, right? So what you're doing is you're heading in this direction, right, with that magnitude, and then you're being perturbed back by these currents and winds. So they're pushing you in this direction, and then they're pushing you in this direction, and as a result, you're going basically east. So it would be, you know, so what we're doing in here, this was, you know, our V1, V2, and then this is our H, right? And the addition of those three is going to be our resultant vector. So that's how it would look like right there. So there you have it. Okay, that's our result in terms of its x and y. And now, of course, we can find out what the magnitude is by taking the square root of this plus, you know, the square root, the square root of both of these. So that's our magnitude. And then we can find out also our angle. So in this case, we can find out what this angle here is, because we know the x and then we know the y down. So, you know, basically as you would go through, so the opposite over adjacent. So we know, so our y, so this was 38.99, I believe, and then our x, okay, was actually a lot. What was that? 99.87, right? So this is in this direction all the way up to here. This is 99.87. So now you can find out the angle, which would have been tan inverse of your opposite, 38.99, over your adjacent, which is 99.87. But that is, of course, the angle towards the horizontal, right? So from the east down. And if you want it in terms of the true bearing, so you would say 90 degrees plus that angle. So that would have been your angle there. But the concept behind this, I just wanted to be able to explain, you know, how would you tackle this on? Now, this was very complicated in the sense that we had two perturbations. If you had one perturbation only, if you had only maybe like a wind, then you basically would just create a triangle, and then you can just use your cosine law. You don't have to break it down into components. But if you do have more than, one, then I guess breaking it down in terms of components, I hope that this made sense to you. All right. Okay, so that is it for this video, okay, in this particular example. So it talks about the concepts of your heading direction and then your bearing direction that you would have for whatever, ships or airplanes. And it does deal typically, okay, with the concept of velocities. So, how are you going to be moving, okay, in those. Thanks for watching. We'll see you in a future video. Bye, everybody.